Welcome. Today we're going to be talking about 9.1.2, both A and B, and hopefully you'll find this to be useful. Having some focusing issues. Let's see if we can adjust that. Not quite sure why it's so messed up, but we work out the details as we go. All right. So today we're going to look at the assignment, and I'm going to talk about several of the problems, point out a couple of hints that are available on the assignment, and also kind of emphasize some of the most important things that go along with this assignment. I'm going to try to keep the video short, but I do want to share a lot of the things I would normally share during class. Now, one of the things that's important to know is that the worksheet 9.1.1c, that was that big one where you had the 2 examples and then the 4 separate problems that looked kind of like this. On that assignment, I would say that if you really get how to find the hidden surfaces, if you get how to find the volume, do a map plan and the different views, right, top and front, then you are probably going to get a 70 or an 80% on our test that we'll be taking. And so it really is one of the most important skills when it comes to doing for this chapter. So even if there are things you're not quite getting in the later assignments, I wanted you to know that if you've mastered that one thing, you're in good shape. All right, so one of the things that I wanted to emphasize here is that finding the surface area and the volume can be really, really critical. And so one of the big things that they're trying to make you understand here on problem 16 is that if I want to find the volume of an object like this, what I need to do is I need to be able to figure out the volume of one layer. If I can find out the volume of one layer, because there really are a bunch of layers here. So if I find out how many blocks are used to make one layer, then I can take that number and I can multiply it by the number of layers. So there are different ways of figuring out the number of blocks, but I can literally just count them. I have 1, 2, 3, 4, 5, I have 6 blocks in one layer. So if we're trying to find the surface area or the volume of this tower, all we have to do is we have to multiply the number of blocks in a layer and multiply that by the number of layers. Now the surface area, keep in mind, when we're trying to find the surface area, we're going to find out how many there are from the front. So these are all ones from the front. Then what we're going to do is multiply that by 2, because the number of blocks that we see from the front, they'll be the exact same number from the back. And then if we want to find out how many there are from the top, so I see there's 3 from the front, which means there'll be 3 from the back. I already counted up how many blocks there were. That sort of tells me how many there are from the top. And so that number we're going to multiply by 2. Now, the tricky part is looking to see if there's anything hidden. So when we focus in on this, we've got this one from the right, this one from the right, and that one. So there are 3 from the right here, but you'll see that here in this place right here, there's one that's been hidden by this gap. So there are these 3 obvious ones plus a hidden one. So there are 4 from the right, and that makes 4 from the left. So you'll multiply 4 times 2. There's 3 from the front, which means 3 times from the back, so 3 times 2. And then 7 on top, which means there'll be 7 on the bottom. And that will be how you'll get your surface area. Now on the back of this, let's work on one of these problems. I'm going to go ahead and pick on one of the ones that's perhaps hardest. So let's take a look at number 3 here. For number 3, if we're trying to figure out what the volume is, what we can do is focus on a single layer. Let's look at the very top layer. Actually, it's a little easier to figure it out. So I know that I have a total of 4 blocks on this side, because that's what they tell me. They tell me I have 3 blocks from this side. So now what I need to do is figure out how many blocks I have on top. Well, if I have 4 rows and 3 columns, or 3 rows and 4 columns, whichever way you want to look at it, 3 times 4 means I have 12 blocks at the very top. And then what I want to do is figure out how many layers I have. And it tells me that they're 5 blocks high. So if there are 12 on the top and there are 5 layers, my volume is going to be the amount on the top multiplied by the number of layers, which is 5. When I multiply those together, I'm going to get 60, and the units are going to be cubed for volume, always. Now, one of the common mistakes that I saw when I was grading homework, there were a lot of students, well, not a lot, but there were some students who were trying to put so I'll write it over here because it's bad, it's what not to do. They were doing something like this. Now, 60 cubed is a lot of blocks. That means that's 60 times 60 times 60 blocks. But we are definitely not using that many blocks to build this. So remember, it is the units that are cubed whenever we're talking volume. Now, the surface area for a rectangular shape like this one is actually not that difficult, but let's go ahead and do the surface area for problem number 2. Now, if I want to find the surface area for problem number 2, what I want to do really is find out how many I have on the top. So let's take a look. I've got 1, 2, 3, 4, 5, 6. I have 6 on the top, which means there will be 6 on the bottom. So however many I have on the top, I'm going to multiply it by 2. So I have 12 on the top, and the bottom. Then what I have to do is figure out how many I have from the front. So I can count those up, and it looks like I have 12. Now, if there are 12 from the front, there has to be 12 in the back. So I'm going to multiply that by 2. And then I have to figure out how many I have from the front, from the right. And it looks like I've got these 4 plus 4 more right in that zone, plus 4 more. So because I'm going to have 4, you can't see them all, but you expect it to have no surprises beyond what you can see. So if there's 4 here, plus 4, plus another 4, that means that from the right, we have 12. And again, we multiply by 2 because there are, when I multiply it by 2, I get 24. Now, there aren't any hidden blocks. I think they say basically it's solid, and 2 of the faces are congruent and parallel, so the front and the back, that's why we get this 24. They're congruent, so as many as we have on the front is as many as we have on the back. So after I've multiplied each of these numbers by 2 to account for the opposite side, I can add these up, and when I add them up, I'm going to get 60. So for problem number 2, and that's going to be the units squared, because we're talking about area, and area of the units are always squared. So hopefully what I've talked about has helped you some with problem number, with the 9.1.2a. Now the next thing we're going to do is we're going to take a look at 9.1.2b. Now I have noticed that there are some students who seem to only be doing the B assignments, and there are homework help hints available for you on the CPM website. So you can get help, but keep in mind that the A assignment is always worth 20 points, the B assignment is worth 10 points, and if there's a C assignment, that's another 30 points. And so just keep in mind that you have to do more than just the homework if you want to get the more than the minimum points possible. So what I'm going to do now is I'm going to go over the very first problem on part B. I apologize for all that noise, but I wanted some scratch paper. All right, so let's look at this problem from the first problem, from problem 20. So what we're going to try to do is find the area of this object. And I'm going to go ahead and make it bigger so I can write all over it, because I always write all over everything. All right, so, and it's not perfect, but it is giving us some pieces of information. So we know that these are right angles. We also know that because this has a double mark and a double and a double and a double and a double, so we know that these marks tell us that the length of this is equal to the length of that and is equal to the length of that. And that's useful information because we're going to use that when we're trying to figure out the lengths of each of these sides. So what I'm going to go ahead and do is break this up into pretty much into two shapes. There is this big rectangle. We'll worry about the bite that was taken out of it later, and this triangle, because what we want to do is find the area of this object. So I'm going to focus on each one separately, and I'm going to begin with this triangle because I know this entire length is 51 units, but I can't figure out what these lengths are unless I somehow can figure out what this length is. So let's focus on this triangle. I'm going to just redraw it over here. And what we do know is that the hypotenuse of this triangle is 30 units. We also know that this angle is 60 units, and that means this is a 30, 60, 90 triangle. So you might want to look back on your notes in your notebook. If you don't have your notebook, if you've thrown it away, then you will have to do the research in the CPM book to find this information. That's the biggest reason why you were asked to make a notebook in the first place, was so that you could use that notebook to reference stuff. So also it looks like this video will be a little bit longer than my hopefully 15 minutes, but that's okay. So this is a 30, 60, 90 triangle. And we learned that when we have a 30, 60, 90 triangle, that opposite the 30-degree angle, the length is always x. It's the unknown, but it's x. And then we know that opposite the right angle, that's always twice the length. The hypotenuse is twice the length of the shortest side. And then the third side is x square roots of 3. So if I can figure out x, then I will be able to figure out the height of my rectangle over here. I will be able to figure out this length and then know what this length is. And that will pretty much give us the clue for everything we need to know. And so if I look at these, I don't have anything over here but an x. All I have here is the x square roots of 3. But I do know that this length is 30 units, and it equals twice the length of this. So I can figure out this length if I just divide both of these sides by 2. And so I discover that x equals 15 units. So this distance is 15, which makes this distance 15. We also know that this length, which is this length here, is going to be whatever x is, 15, multiplied by the square root of 3. So I'm going to go ahead and write that on my diagram as well. So now that I've used what I know about 30, 60, 90 triangles, I can focus on finding the area of these two shapes. So we began with the triangle, so let's continue with the triangle. The formula for finding the area of a triangle is 1/2 the length of the base times the height. Now I just want to remind you that this formula, the base is one of the sides of the triangle, and the height is the perpendicular distance from this side to the opposite vertex. Now what's awesome is that if you have a right triangle, you can calculate the area of the object easily, because the base and the height are the two sides that create the right triangle. So the area of my triangle, my area is going to be 1/2 of my base, which is 15, and my height, which is 15 square roots of 3. All right? So if I multiply these together, 15 times 15 is 225, square roots of 3 divided by 2. Now I'm not going to calculate what that is as a decimal. You can if you wish, but right now I'm just going to leave it at that, and because it's an area, I know that the units are squared. So I have now found this area, 225 square roots of 3 over 2, and the units are squared. That's the area of this part of my shape. So now let's focus over here on this shape. So we know that this length is 15 square roots of 3, and we know that this length from here all the way to here is 51 units. So if I want to figure out what this length is, what I have to do is take 51 and subtract 15. And when I do that, I'm going to get, what will I get? Let's see, I'm going to use my handy dandy calculator. If I take 51, subtract 15, then I get 36. So I know that this distance is 36 units. So if we didn't have this little bite that was taken out of this of the rectangle, then we could just multiply the two dimensions, the length and the height, and we would get the area of the rectangle. But we do have to deal with this. Now we do know that this distance is exactly the same as this, which is exactly the same as this. So from here to here is 36 units, but it's divided into 3 equal pieces. So I can take 36 divided by 3, and I'm going to get 18. Pretty sure that's true. Let me use my calculator, make sure I don't mess this up, because I'm easily messed up. No, it's 12. Okay, I don't know where I got 18, but it's 12. All right, didn't seem right. Yes. I don't know where 18 came from. But anyway, so we know that this is 12, this is 12, and this is 12. So I'm going to go ahead and write these here. Now the reason why this matters is I'm going to need to subtract the area of this bite from the area of the rectangle. So happily, I also know this dimension is 12 units. So I can figure out the area of this square by taking 12 times 12. I know that this is 144 units squared. All right, so now what I need to do is find the area of the big rectangle. To do that, I'm going to multiply length times width. So if I take 15 and I multiply that by 36, I get 540. So this is 540. The 15 times the 36. There's also going to be a square root of 3, and the units are squared. So this is the area of the rectangle. Now, I'm not going to solve the entire problem for you. I'm going to leave it to you to get the final answer. But basically, my area is going to be the area of the triangle plus the area of the big rectangle minus the area of the small rectangle. And I wanted to add a couple of additional points for you. Number one, you've got these math notes here at the bottom. They help you. Problem 22 is based entirely on these math notes, so you will need them in order to be able to solve problem 22. And pretty much that's it for my hints for 9.1.2b. Do let me know if this is useful. I can continue to try to make additional videos for the additional assignments, not only the ones assigned that are due tomorrow, but I can also do them for the assignments for this week. And again, it's not perfect, it's not professional, because this is not my day job to produce movies or YouTube videos, but I did want to give you the opportunity to help you to solve these difficult problems with a little bit of help. And so I'll give you one last hint. In this problem, you're going to add this plus this plus this plus this plus this. All of those added together are going to equal 540. So it's going to be a big old equation. You'll combine like terms, solve for x, and then you'll have the answer. All right? And if this angle is 4x plus 20, that makes this one 4x plus 20. And these two angles have to add up to 180. So, bunch of food for thought. I hope that you got something useful out of this. And take care. As teachers, we really miss you guys a lot.